Hello, ladies and gentlemen of Algebra 2. We are looking at 7.6, talking about looking at graphs of polynomial functions. We need to be able to figure out real zeros, maximums, and minimums, and kind of what they look like. Real zeros are just where does it cross the x-axis. Maximums, of course, are going to be where they top out. Minimums are going to be where they bottom out. So that's kind of what you're looking at there. Now, get into it here. So the percent of the United States population that was foreign-born since 1900 can be modeled by this function, where t goes from 0 to 1900. Notice that the graph is decreasing from 5 to 75, and then it begins to increase. The points at t equals 5 and t equals 75 are turning points in the graph. So 5 will be right about here, 75 is right about here. So in between it decreases. So one turning point, two turning points in the graph. That's kind of what you're looking at. So what you're looking at, real zeros, where it crosses the x-axis. Relative maximum is where it changes from increasing to decreasing. So it kind of goes like this, increasing and then stops increasing and starts going back down. Relative minimum, where it bottoms out and then comes back up. Okay, relative maximums, relative minimums, also called turning points. So be aware that they might be called that at some point in time. So taking a look, graph the polynomial function of x to the fourth, x to the third, minus 4x squared, minus 4x by making a table of values. So take a moment and fill that in. So I've filled in my table, so now I'm going to plot my points. So at negative 2.5, so that's right about here, I'm at 8.44, which is way up off the graph, but that's fine. At negative 2, I'm at 0. At negative 1.5, I'm at negative 1.33, so I'm right around here. At negative 1, I'm back to 0. At 0.5, I'm at 0.9375, which is not quite 1. At 0, I'm at 0. At 0.5, I'm at negative 2.8, so I'm all the way down here, almost to 3. At 1, I'm down here at negative 6. At 1.5, I'm back to negative 6. I'm down to negative 6.563, which is right about here. And by 2, I'm back to 0. So if I start playing connect the dots here a little bit, I'm going to come down, down, up, like so. There should be a straight line going back like that. All right, so if I'm determining the number of real zeros the graph contains, well, there's 1, 2, 3, 4. So I'm going to be at negative 2 and 2, at negative 1 and at 0. There are my zeros right there. So that's what I'm doing. Now I use my calculator a lot to kind of do the heavy legwork. You can start filling in the blanks as well, but that's just kind of what I do. So sketch a graph of the function x to the third minus 5x squared plus 3x plus 2 let's do that. Delete. So now if I graph this, determine the integer values of x between which each real zero of the function is located, then estimate the x coordinate and at which the relative maxima and minima occur. So when I look at this, so when I sketch this graph, it's going to look something like this. So it's going to look neighborhood of back down at 1, 2, it's going to come down here, then back up like so. It's going to look something like this. Obviously, with drawing on the iPad, it's a little bit tougher than drawing on paper per se. But you can always plot some points. So when I look at zeros here, what I'm trying to figure out is where does it cross. So as crossing right there, and right there. So it appears 1 and 4 are going to be one of them. And then negative almost 0.5, but I can say it's actually negative 0.4. So those are going to be my zeros, okay? So that's what goes in this top bar. Maximum and minimum. So here's my maximum up here. My minimum is going to be down here. So I can calculate those by just kind of estimating where I'm going. So it's going to be about, you have a maximum at about 0.5, and you have a minimum, I'm going to say, to probably about 3. So yeah, right around 3 is going to be your minimum. So x value is 3, x value is approximately 0.5 there. That's going to be there. Now I'm going to use my calculator, and I'm going to get much more specific, and I can show you how to calculate that. So if I sketch a graph here, let's take a moment and do that. So now when I graph this, I'm going to be right here. At 1, I'm at -1. At 1, I'm at -1. Let me erase that, because I don't know if you noticed this or not. On the graph, each one is 2. So at 1, I'm at -1. At 2, I'm at 2. At 3, I'm at -3. At 4, I'm at -10. So this graph is actually going to go like this. It's going to go down. Kind of looks like that. Wait, hold on, not done yet. Sorry. And then back, by the time I get to 5, I'm back up to 11. So this is actually going to be a turning point, and then go back up. All right, so determine consecutive values for which each real zero. So I'm going to say it crosses between 0 and 1. Okay, and then I'm going to say that another one crosses between 1 and 2. Okay, I can't figure out those exactly, so I'm just trying to guess, do a best guess here. So, and I'm going to say that there's another one that crosses between 3 and 4. And then I'm trying to guess which one's going to be. There's probably going to be one more between 4 and 5. And I get that it's hard to kind of tell, but you've got to be able to look and see, kind of guess each one is 2. So about halfway in between each block is going to be 1. So that's what I'm saying. Between 0 and 1, 1 and 2, 3 and 4, 4 and 5. Where are my maximums at? Or my minimums? Or my maximum? So I'm going to look. So I get a maximum at 2, and my minimum, I'm going to have 2 minimums. We have 1 minimum. This one out here is going to be at 4. And this other minimum is going to be at 0.75. And again, I can show you how to calculate those on a calculator. On the TI-84, there is a calc function up at the top in that top row. And if you go to calc, you can find an exact 0 and a maximum and a minimum, and I can show you guys how to do that. So come ask me questions if you want to. So let's take a look here. You've got this function, number of years since 1960, average fuel consumption, sketch a graph, determine the turning points and end behavior of the graph, and then what trends are suggested in there. So let's take a look at this. So 0.025 x raised to the third. So minus 1.5 x squared plus 18.25 x plus 654. So if I graph this, sketch a graph, so now as I sketch this, all right, I'm going to start back here at time 0. And I fully admit I did this on a graph, and I'm just kind of sketching it off the graph. So it starts at about 654. So it starts right here. Then it kind of goes up. Then it bottoms out. And then it goes up again. It kind of takes off. So if I look at where are my turning points? Well, one turning point is going to be at about 7.5. That's going to be one turning point. Then this other turning point down here is going to be at, hang with me, calculate, approximately 32. Okay, and then it's going to take off again. So it bottoms out right around 520, and it's going to take off again. So end behavior of the graph, so this is going to keep going like so, and this is going to keep going like so. So as, you know, t goes towards infinity, this function's going to go towards positive infinity. It's going to go up. What trends in fuel consumption does the graph suggest? That there's an uptick that recently, since 1960, so that would make this the year 2000. So ever since the year 2000, global usage of fuel, or United States usage in fuel, has increased sharply. That's kind of what it suggests. It bottomed out for a while, and then we kind of took off, starting almost in the year 2000. So is it reasonable to assume that the trend will continue indefinitely? No, because there's only a limited amount of gas in the world. So it's not going to continue, but it's a trend that's kind of disturbing. Okay, sorry. So I graphed it. I've got one turning point, 7.5, one turning point at 32. Okay, and then remember, it's 1960, so year 40, it's about 2000. So there's your turning points. End behavior, this is going to take off. This is actually going to keep going down, but it's not realistic because we're starting at 1960. They will not continue indefinitely, only because there's only so much in the world that we can take. All right. Homework time, play around. You let your calculator do a lot of the legwork, and you are closing in on the end of Unit 7. Thank you.